My name is Kevin, and today I would like to talk to you about WinDbg, about your dream debugging tool, and what they could have in common. For this talk, I'm going to assume that all of you have used WinDbg at least once, but I'd like just to do a quick survey. How many of you consider yourself as regular users of WinDbg? If you could raise your hands. Okay, so still a few regular users. For the other, I hope that what I'm going to show you will make you want to use it more. So you may be a bit confused by what I'm showing right now. This is the oldest version of WinDbg that I could find. This is version 4 that was released in 2001. And you probably don't recognize it because it has changed a lot through the years. And if I show you WinDbg 6 that was released in 2005, you can see that the UI has been changed a lot. So yeah, so the gray in the background is slightly lighter, which is probably the reason why you didn't recognize it. But I still see some confusion, so those are probably the guys who started with WinDbg 10 that was released in 2015, 10 years after this one. And once again, we see massive changes in the UI. So seriously, we've just witnessed in 3 slides 14 years of evolutions of WinDbg. That's about the time between Windows XP and Windows 10. And we can see that there has been absolutely no change in the UI or the UX, even though every new version brought new features, supported new debugging scenarios, but no improvement on the UX. And that's a problem because the UX is pretty bad. I think we all have our list of things we don't like about this software. Personally, I really don't like the fact that there is only one window to type commands, even though we are in an era where everybody has 2 or 3 screens to code. Also, you have no history. So imagine you are in a long debugging session, about half an hour, then you want to go back to a command that you typed at the beginning, and you have to scroll all the way in your command buffer to find the exact right moment where you typed it. And you may think you can just re-execute it again, but personally, I deal with a very large memory dump that are 20 or 30 gigabytes of RAM, and some commands take minutes to execute. So re-executing them is not an option. And because of that, I always have a few instances of Notepad open aside so that I can copy and paste the important commands and come back to them. One last thing, that would be scripting. I don't know how many of you tried using scripting in WinDbg, but I'm fairly confident that none of you consider themselves efficient at it, because scripting is completely broken in that software. And because I am a regular WinDbg user, I've tried to fix this application. I've tried to extend it, but the only available extension point is what I'm going to call in this talk native extension or classical extension. Those are, for instance, SOX or SOSX. It's just a DLL that you can load to add some commands to your debugger, but you cannot tweak the UI in any way. So because of that, I was very hyped when Microsoft revealed the preview of the new version of WinDbg, with this time, for real, feature a full rewrite of the shell. But if you start using it, then you realize that as with every new feature, every new version, you get new features, but the UX is still identical, and you still have a single window to type your command, you still have no history. The scripting has been improved, but it's still pretty bad for managed debugging. And I mean, it's just a stupid thing, but if you use WinDbg for managed debugging, just think of how many times so far you've typed .by SOS Sierra. So it really shows that the UX is level 0. But when I see that, I also see hope because there is a ribbon. And from my personal experience, I don't know where it comes from, but except for Office or the application that come with Windows, every other application I know that has a ribbon has been written in .NET. And the fact is, any .NET application can be hacked, can be tweaked with a reasonable amount of effort. By reasonable, I call, for instance, writing a custom loader that will set some context, then call the application entry point. Or you can replace the application assemblies by your own, where you implement the same interfaces. Or today, you even have software that completely decompile the application and generate a solution that you can directly open in Visual Studio to recompile the application. It's just that powerful. And if everything has failed, you can still edit the IL. And it may sound scary if you've never done that, but it's much easier than native assembly. So knowing that, I started digging into the application to find how I could tweak it. And so the first thing is to confirm that this is a .NET application. So if you go in the application folder, you get this configuration file. If you open it, you have directly the confirmation that this is a .NET application. So that's great. So the next step would be to open it in a decompiler. Personally, I use .pik, but there are plenty of them available. And if you search for the application entry point, so it's usually in program, and decompile it. So we have some stuff about CRUD SKU. I don't really know what it is. But the important part is we create a new shell application, and we call run on it. And if you look at shell application, you can see that it inherits from system.windows.application. So now we know that the UI has been written in WPF. Also, you may notice those import and import many attributes. If you ever used MEF, then they are very familiar to you. MEF is Managed Extensibility Framework. It is a composition framework that was released by Microsoft. And what it does is basically allowing you to easily import types at runtime from other assemblies that you don't know at compilation time. So it's often used for plugin systems. And the way it works is using attributes. So there are two important attributes. There is the export attribute. Whenever you mark a type with the export attribute, then MEF will make it available in an internal catalog. And then whenever you use the import attribute on a field, then MEF will search its catalog for a type that matches the same type and will magically inject an instance of that type into your field. So if we go back to the code, for instance, here we have this idbg command line parser field with an import attribute. It means that MEF will scan its catalog, find a type that defines its interface, and then inject by reflection the instance into that field. So that's really nice because it means that if we find a way to inject our assembly into that catalog, then we can run our code inside of WinDbg. So the next step is to find out how this catalog is constructed. And so if we follow the application workflow, we arrive on the startup event, which call dbgx initialize. And inside, so there's plenty of stuff, and we see this create composition container method. So MEF is a composition framework, so that looks good. And inside of it, the first hint that we are on the right track is this skip local extension flag. So clearly, WinDbg has some notion of extensions. If we move further, we see that we create a new component composition container, and we call compose async on it. If we look at this, okay. So we have this get assemblies in catalog method. So it's good because we're trying to find how to add our assembly to the MEF catalog. And there are two flags, include local extension like before, and include user extension. So it's even better. It shows that WinDbg as an extension mechanism aimed at developers, at users. And then if we look at the method, I won't go into the details, but basically it's scanning two folders on your disk, the extensions subfolder of the application directory and the dbg/UI extension folder of your application profile, and it will load the assemblies from there and add them to your catalog, to the catalog. So what have we learned so far? We learned that the new WinDbg, codenamed WinDbgX, is a .NET application with a WPF UI. We learned that it uses MEF for composition. And we learned that it has some kind of undocumented API to write user extensions. And so in the remainder of this presentation, we will dig into that undocumented API and find out how it works and what we can do with it. Quick word of warning. When I started tweeting and blogging about that stuff last year, I got notified by Andy, which is a project manager on the WinDbg team. And he told me that they are planning to document the API. They are not doing it yet because this is a preview, so they want to feel free to break the API as they want. But so it has been 1 year already, and while they made a lot of changes to the API at first, now it looks pretty much stable, and I don't think they will do other big changes. But be warned that whatever I'm going to show you could break tomorrow at Microsoft discretion. Okay, so we know that we are going to use MEF to inject our code inside of WinDbg, but we still need to know what interfaces we can use. They are all in two assemblies. dbgx.interfaces contains the interfaces that you can use to extend the UI, and dbgx.interfaces.internal contains other interfaces for the UI and also all the stuff to control the application and the debugging engine. One last thing, we need to know how to store our extension. So as I said before, there are two folders. The first one is the extension subfolder of the application directory. So this one is really painful to use because the new WinDbg is a Windows Store application, and the store sets very restrictive permission on the application folder. So you can go around it, but it's a lot of pain. And also, WinDbg only scans for assemblies that start with dbgx in the name. So clearly, we are not intended to use it, and it's only for extension that comes with WinDbg. So there is also the dbg/UI extension folder in the application profile. Here you have no file restriction because it's your application profile, and it just loads any assembly. So clearly, we are intended to use this one. And so the first extension I would like to write is a button in the ribbon that when you click on it, would load SOS. So you don't have to type .load by SOS CLR anymore. And whenever SOS is loaded, then we gray out the button. So it's really simple, but it's a nice way to start writing extensions. Also, one thing I didn't mention, if you look into the application folder, you can see this extension folder. And inside there is already one extension provided. And what it does is it adds this feedback hub button in the ribbon. So it's a nice start if you want to learn how to write extensions. Anyway, so I have a solution ready. For every project I'm going to show, I did the same thing. That is, first I reference dbgx interfaces and dbgx interfaces internal. I also reference dbgx util, which contains a few helpers for WPF, such as custom commands. So I like to use it because it's provided, but you can use just any WPF library. And I use Fluent. This is Fluent Ribbon. It is an open source library that WinDbg is using for the ribbon. Also, in the properties of the project, I'm setting post build event to copy automatically the files to my application profile, so I don't have to do it by hand every time I compile. And lastly, I'm setting the WinDbg executable as target action. So whenever I press F5, it's automatically attached to WinDbg. Okay, so we want to make a button to load SOS. So the first thing to do is to create a button. So I'm going to go fast on the WPF stuff. I'm going to assume you already know that, or if you don't, there are better teachers than me. And I'm going to focus on the things that are specific to WinDbg. So for starter, I'm going to zoom a little. So I create a toggle button. It is a button that comes with free and ribbon. So this is WPF. You can use any kind of controls, but I think it's better to use the ones that come with a ribbon library, just to make sure that they integrate perfectly into the application. I set the header to SOS. I bind the isCheck property to the isLoaded property of my view model. And I bind the command to the load SOS command of my view model. So whenever I click on the button, the load SOS command will be invoked. Now the interesting stuff is in the view model. So I'll come back on that attribute later. So I implement inotify property change. I create the command. Async delegate command is a helper provided with WinDbg, but it's just an ordinary WPF command. Load SOS is called when I click on it, and can load SOS determines if the command is activated or not. So if I return false here, the button will be grayed out. So this is just a property. In the can load SOS method, I just return not is loaded. So is loaded is my custom property. So what I'm saying is whenever SOS is loaded, I want the button to be grayed out. And there is the load SOS method that is not implemented yet. So the first thing to do is to add this ribbon tab group extension metadata attribute. It's telling WinDbg where you want your button to be. So here we're saying that we want it in the home tab. To find the name of the tabs, it's a bit painful because you have to decompile the main application and look into the WPF view. But they all use the same naming. It's the label that you see on the tab, following by ribbon tab. So home, it's home ribbon tab. View, it's view ribbon tab, and so on. So it's pretty easy. Inside of that tab, I want to put my button in the help group. And the last parameter is the order, whether I want it at the beginning of the group or at the end of the group. After I've done that, I need to implement idbg ribbon tab group extension. And I need to add the export attribute so that MEF know that I'm implementing it. So there we go. And in that extension, it defines just one property, which is controls. And in that property, I'm supposed to return the list of controls that I want to add to the ribbon. So here, I just return my button. And just to make sure that everything is correct, I launch WinDbg. And here we can see that we have our SOS button in the help group and in the home tab. So now we need to implement what happened when we click on it. So we want to load SOS, so we need a way to execute commands. To execute commands, we can use the idbg console. And so I use the import attribute so that MEF will automatically provide an instance of that inside of my field, and I can directly use it. So if I look, then console defines a few methods, for instance, a get prompt to ask the user to type something. And you see this execute local command and execute command. So what's the difference? So as the name indicates, there are two kinds of commands. Some are interpreted by the UI, and some are interpreted by the debugging engine. For instance, if you type .hh in WinDbg, it will bring the help file. This is executed by the UI. Likewise, if you type .cls, it will clear the screen. It is also executed by the UI. But then if I type .load, it will load a native extension into the debugging engine. This is executed by the debugging engine. Then if I type dump heap to dump the contents of the heap, that likewise, it will be executed by the debugging engine. If you use execute command, then the command is sent to the UI, which will try to execute it. And if it doesn't understand the command, it will forward it to the debugging engine. If you use execute local command, then it is directly sent to the debugging engine. So in that case, we want to execute .load, so we will use execute local command. Also note that there is an uncapture output version of the method. What it does is, instead of displaying the output in the command window of WinDbg, it will just return to you in a variable, and then you can do whatever you want with it. So I execute .load by SOS CLR. And after that, I set my isLoaded flag. So now, if I launch WinDbg, I open a memory dump. And if I click on the button, then we can see that it has automatically executed the .load by SOS. And my button is grayed out. So that's what I wanted. There's still something that is not working. If I load a memory dump and then out of habit I quickly type .load by SOS CLR myself, then the button is not grayed out. We didn't detect that I manually loaded SOS. So we need a way to listen to commands typed by the user to detect this special case. So how to do that? So for that, we need to implement another interface, and that is iDbg command execution listener. And once again, we add the export attribute to tell MEF that we are implementing it. There we go. And it defines one single method on command executed, which takes the command being executed as a parameter. So here, all I'm going to do is check if that command is .load by SOS. And if it is, then I set my isLoaded flag to true. And now, if we put everything together, then I load my memory dump. Out of habit, I type .load by SOS CLR, and then my button is automatically grayed out. So, of course, this is not the most useful extension, but just like this, we've learned how to add a button to the ribbon, we've learned how to execute a command, and we've learned how to listen to command. So just with that, there is already a lot of scenarios that we can implement into our extension for WinDbg. Also, there is a lot of text on those slides. It's just the thing that I show you, and it's so that you can go back to it afterward if you want to start writing your own extension. Okay, so let's try to do something a bit more useful. So as I said, one of the main things I don't like about WinDbg is how you don't have a history of command. So we will fix that. I want a user extension that log every command that I'm typing and their output. And then I want to be able to open a panel which will show me all the commands I typed. And whenever I double click on one, it will open the output of that command in a new window. And since we're there, we will also turn that new window into a new command editor. So just a screenshot of what that should be. So you should have this history panel, and every time I type a command, it's added in it. And if I double click on one, it opens a new window with the output. So I prepared a project for that. So like before, the first thing to do is to add a ribbon, add a button, sorry, in the ribbon to open the panel. And so I prepared the button. So like before, I use a freelance ribbon library. This time I use a simple button. I set the header to history. This time I provide an icon. And I bind it to the show command of my view model. Inside of the view model, just like before, I add the ribbon tab group extension metadata attribute. This time I'm saying I want to be in the view tab, in the Windows group, and towards the end of the group. I also implement IDBG ribbon tab group extension. So the action of my command is not implemented yet. And in the control properties, I return the instance of my button. So it's identical to what we just did. So now, if I want to display a panel, I need to create that panel. In WinDbg, the panel are tool windows. So to make one, I first need to create a user control and make it inherit from tool window view. So tool window view is provided in dbgx.interfaces. And here it's just WPF stuff. I'm just creating a list box. I'm binding it to the history property of my view model. And then there is some voodoo to bind the double click on an item to the open command of my view model. And I give the output of the selected item to my command. So the stuff is happening in the view model. So we have our open command. We have our list that is bound to the lister box. And a bit like the button, we first need to add a metadata attribute. This time is name part metadata. And it is used to give a name to the tool window. So here we name it history window. And the name is important, so that I copy it. And then I need to implement IDBG tool window. So it's self-explanatory. And I need to export it. All the interfaces in WinDbg have pretty good names. So just by browsing the dbgx interface and dbgx interface internal files, you can get a good feel of what is possible or not possible with this application. So if you use good naming, then it's worth any documentation. So I implement it. And it has a single method that is getToolWindowView, which takes a parameter that we're going to ignore for now. And we are expected to return the instance of tool window. So here we return a new history window. Okay, so now we have our tool window, but we still need to find a way to display it. And for that, we go back in the button, and we are going to use the IDBG tool window manager. As the name indicates, it allows us to manage tool windows. There we go. And it has plenty of methods that allow us to manage all the tool windows. For instance, get all the instances of open windows. But in our case, the one we want is open tool window, which allows us to open a new one. And it takes two parameters. The first one is a name. This is the name we put in the metadata attribute. And the second one is an optional parameter. So we are not going to give one. But if I did put one, then I could retrieve it here. So I just open the tool window. And if I check that everything is working properly, so if I go in view, I have my history button. And if I click on it, it opens this tool window that I can either move or dock or whatever. So now we just need to add a content to that tool window. So if I go back to it, so we're going to need two things. We need to listen to the command that user type. So we did that previously. For that, we use the IDBG command execution listener. And we need to listen to the output of those commands. And for that, we're going to use the IDBG DML output listener. So don't forget to export them. There we go. So I implement them. I said I implement them. Okay. And so, oh yeah, we're going to need two fields. The first one is command name. It will contain the name of the command that is currently being executed. And the second is command output, which will contain the output of the command currently executed. So the first one is onCommand executed. It's called with the name of the command, so I just assign it to my field. Then onDML output is called for each line of text that is displayed by the debugging engine. So everything that arrives in my command window in WinDbg. So here, whenever it's called, I append it to my string builder. And also, commands are executed asynchronously, and they can take minutes to execute, and they tend to display text as I go. So for instance, your command will display one line of text, and 1 minute later it will display some text, and a few minutes later it will finish executing. Because of that, we need an event to tell us the command has finished executing, and so any line of text that you receive past this point belongs to another command. So when the event is raised, we just add the command to our history list. So I have the name of the command and the output. And also I clear my string builder. There we go. So with that, we should have every command logged in the panel. But when I double click on one, I still want to open the output in a new window. So once again, I need to make a tool window. So this is the one. So I implement tool window view. Here, this is WPF stuff. I have first a rich text box in which I will put the output of the command. And then I add another text box, and I will execute the commands that are typed by the user in that text box. If you will look at the code behind, so to execute command, we already see that we need to use the IDBG console for that. So this part is straightforward. Whenever the user types something in the text box and press return, I just call execute command on the IDBG console. And we have this code for parsing DML. So I don't know if you know what is DML. When you execute some commands in WinDbg, they are displayed with hyperlinks. And when you click on those hyperlinks, it executes new command. So this is possible thanks to DML. It is a kind of markup language that is close to HTML. And so the commands return their output in that language. So here what I'm doing is I'm searching for the exec tags in the DML. So it corresponds to hyperlinks. And I convert them to hyperlinks objects that I add to my rich text box. So this is just parsing and WPF stuff. And then in the view model, I inherit IDBG tool window just like before, and I give a name to my window, command window. And also in the get tool window view, this time I use the parameter because it will contain the output of the command I want to display. and so I give it to my command window. So if I go back to the view model, I want to open that window. So I'm going to use again the tool window manager. I import it. And so whenever I double click on an item, I just open this window and I give it the output of my command. So if I forgot nothing, if I go back to WinDbg, I open a memory dump, I load SOS, then I open my history panel, so now it's empty, and I type a command, and it gets added here, and then I type another one, it's added here, and then say that much later I want to go back to one of the commands I executed, so I just double click here, and it opens a new window with the output of that command. And since I've added this text box for commands, I can just, for instance, execute dump heap empty that, and it works just like the command window of WinDbg, and it supports DML, so I can just click on the hyperlink and it works. So just with, I'd say, a reasonable amount of lines of code, we turned WinDbg into a fully multi-window debugger, which is a bit of an improvement. But we can go even further. So what have we learned? We've learned how to open a tool window, and we've learned how to capture the output of the commands. So now I want to make one another extension. So as I said, scripting is broken in WinDbg. Because of that, whenever I need to script something, because for instance I need to inspect a lot of objects to find something, what I do is I use ClrMD. ClrMD is a C# library that allows you to open a memory dump and inspect the data structure in an object-oriented model. If you want to know more about ClrMD, my colleague Christophe Nazar has a talk about it later today. So you can go and see it. And so whenever I need to script, what I do is I start Visual Studio, I create a new project, I import the ClrMD NuGet package, then I write all the boilerplate code to initialize ClrMD. I write my script, execute it, see the output, and go back to WinDbg. So this is a huge break in my workflow, and therefore a waste of time. So I heard that some people use ClrMD in LeakPad to save time, which is slightly better than using Visual Studio. But still, I want to be able to write my C# code directly inside of WinDbg. And we already have all the tools for that. So let's do it. So before going any further, we need to understand the process model of WinDbg. So if you use the previous versions of WinDbg, you know that there is a 32-bit version and a 64-bit version available, and you need to use the right one depending on the process you want to debug. So if you want to open a 64-bit memory dump, you can only use the 64-bit version of WinDbg. In the new WinDbg, you've got only one application, and you can just debug 32-bit and 64-bit process. So how is that possible? So the process that you launch is dbgx.shell.exe, which is compiled for any CPU, and just run the UI. And whenever you open a crash dump or you attach to a running process, it checks the bitness of your target, and then it has two versions of enghost.exe that comes with the application. One is 32-bit, one is 64-bit, and it launches the right one depending on your target. And then it used name pipes to communicate with a child process, to send commands, and to get the output back. So that's pretty nice, but why is that a problem for us? It's a problem because ClrMD needs to access to the memory of the target, so either the running process or the crash dump. It means that ClrMD needs to run inside of the debugging engine. But right now, all the extensions we've wrote are running inside of the UI. So how can we bridge that gap? So one way is to use the only extension point that has been available in WinDbg for years. That is what I called earlier native extensions. So we're just going to write a native extension which will export an execute code command, and we will call that command from the UI. And so this way we will have a way to run our code directly inside of the debugging engine. So first step, we've done twice before already. We need to add a button to the ribbon. So we use the DbG ribbon tab group extension. And then when we click on it, we want to open a new tool window. So we use DbG tool window manager. In that tool window, we put a little C# editor. So I use Avalon Edit, which is an open source library that provides syntactic coloration. And I've added the run button on the bottom. Then, to use ClrMD, you need to run with the same bitness of, as the target, and also to run native extension. So for instance, if you already used SOSX, then you know that there is a 32-bit version and a 64-bit version. So for our extension, we need to do the same thing. And to know which one to load, we need to know whether we have a 32-bit crash dump or a 64-bit. So for that, we need a new interface that is DbG target query. So we use it with the import attribute like before. And it defines a lot of methods to get more information on the target. But the one that is interesting for us is the isPointer 64-bit async. So as the name indicates, it returns true if the target is 64-bit and false otherwise. Once we know that, we can load our extension into the debugger. So we already did that with SOS. We just need to use the DbG console and execute the load command. So we give the full path to our extension, and we make sure to pick the 32-bit version or the 64-bit version. So from that point, after we execute this command, we are loading our extension into the debugging engine, and then we can use it to run code. But to run the code, we still need to prepare it. So we save the C# code into a temporary file on the hard drive. And then we call our custom command. Here I've called it compile and run. And we give it the path to the file we saved. So everything I've shown until this point was in the UI process. So now we execute the custom command, and so we switch to the debugging engine. So from that point on, everything is happening in the debugging engine. So the first thing to do is to compile the C# code. There are plenty ways of doing that. I recommend using the C# code provider that comes provided in the BCL. So it's a convenient way to transform C# code into an assembly file. And once we've done that, we just need to initialize ClrMD and give the CLR heap object to our custom code. So how to initialize ClrMD? Just make sure to check the talk from Christophe later. Okay, so let's see it in action. So I've already prepared the project. I just compile it. All right. And is it startup project here? Okay, so let's say we are in a real situation and we are investigating a leak of file streams. So our application is not disposing properly some file streams and we're trying to find out why. So first thing, load SOS. Then it's maybe a bit small. We dump the heap to find the instances of file stream. So here we can see that we have 35 instances of file stream. And then if I dump the instances, then I wonder if I can make it just slightly bigger. Where would that be? I don't know where, never mind. And then if I take just one instance of file stream, so how to know if a file stream is closed? For that, you need to check the save file handle that is in the underscore handle field. And that handle has a state field. And if the first bit of the state field is set to 1, then it means that the handle is closed, and therefore that the file stream has been properly disposed. So now just imagine going back to this list of 35 file streams and check them one by one to check if the first bit of the handle state has been set. So that would take a lot of time. Instead, what we can do is just open our new panel and start scripting. So what I want is all the instances of file stream. So for each file stream in, so heap is a CLR heap object provided by ClrMD. And get proxies. So I'm not just using ClrMD, I'm also using DNAMD, which is a library that I wrote to allow you to use the objects from ClrMD using the C# dynamic keyword. So this way we can just manipulate them just like they were real objects in your memory space. So for instance, here we want to retrieve the content of the state field. So what we do is just state equal file stream. Then we want the value of the handle field. So I just tap handle like I had the real object, and then just state. Then I need to check if the first bit of my state is set. So is that? And if it is not set, then my file stream is not disposed. So that's the one I'm interested in. So if not one, then I want to write the address of that file stream so that I can inspect it. So I just call writeLine. I want to format the address in hexadecimal. And to retrieve the address, I just cast it to unsigned long. Just cast my object. And that's it. And if I execute it, and if I made no mistake, then you can see here all the instances of file stream that has not been properly disposed. And so then you can dig into them individually and try to find out what is the problem. So it literally took 2 minutes to write this script, and just imagine how much time it would have taken scripting with the real WinDbg API. All right, so to wrap it up, what's next? I'm still waiting on Microsoft to communicate on the extension points. I'm also trying to convince them to make WinDbg open source, but I don't know if they will do it. But you don't have to wait. Even starting today, you can write your own extension. I think it's a good thing because it helps showing Microsoft that there is interest in extending WinDbg. And also it helps providing early feedback on what is good or not good about those API. So it's good to do that now while they can still break them and make major changes. And who knows, maybe someday we can imagine having an extension store like in Visual Studio where you would be able to easily add the extension you like. If you want more information, you can check this GitHub repository. It contains all the code of the extension I showed, plus some more features. Also, you will find in the README the link to 3 blog articles that I wrote that are basically repeating just what I show you, but it's good to have it in a written form. And if you have any question or want to interact, don't hesitate to ping me on Twitter. And so we have plenty of time if any of you have questions.
Raise your hand and get the microphone.
Yes. So maybe I have a question about remote debugging. So what you can suggest on this task, and yeah, what kind of extensions could we make, and maybe we could have some problems with async in WinDbg. So yeah.
So there's 2 questions here. So one about remote debugging and one about async. So about remote debugging, well, it really depends. I think that WinDbg already supports remote debugging. You can connect to a remote instance of the debugger and manipulate it on your side. So that's pretty nice. I'm not sure what more you would want.
So the question was, should we use the same interfaces as for local debugging, or there are some other stuff?
Oh, okay. Yeah, you can use the exact same interfaces because the target is abstracted to you. But the part about the C# script won't work because we are saving the file locally.
Yes.
And so on the remote process, you cannot see it. But I just did it for convenience. I don't know if there is a limit of size on the parameter that you can give to a command, but I could just pass my full C# code as a parameter to my command, and then it would work on a remote debug scenario, assuming that you have the native extension on the remote server.
All right. And one more question about the heap. So as I understand, so this is a dump of the heap, correct? So
This is a, sorry?
So this is the dump of the heap, and we're executing the C# code on the dump. So
yeah.
Not on the running program. Okay.
Yeah, so that's,
just to clarify.
So that's ClrMD, and ClrMD allow you to attach either to a live process or to a crash dump, and then inspect the contents of its memory.
Thank you for your lecture. One question: how did you made a syntax highlight in run C# script?
Okay, so I personally didn't. I just use an open source control that is named Avalon Edit, and if we look at the editor, so here I just use a text editor control that is provided with it. I set syntax highlighting to C#, and it just works.
And I'm also really interested in extending the already existing WinDbg program. Could you suggest any solutions for using the WinDbg DLLs to provide some kind of web UI for it, maybe for running it in the cloud, and so to have access from multiple developers to the cloud version, kind of using the WinDbg DLLs, running them in the cloud, and then yeah, having a shared UI for all the companies, so anyone could access it.
So you want to share your debugging session?
Yes.
So that's something I'm thinking about. I've not started working on it yet, but so basically there was this one time where we had a really tricky issue to investigate, and half the team was working remotely, and so we have a screen sharing solution, and we did some debugging, and it was incredibly efficient because when we try in real life to debug something with the whole team, there is always one screen, one guy who is typing the command, and then everybody's mind go in different direction. Everybody has his own hypothesis, and we just can't move on because there is just one screen. Whereas on a remote, whenever somebody has an ID, it could, on its own computer, check some stuff, look on the internet, and so it was incredibly efficient. And so I'm thinking, since I already have a multiple window editor, I would like a way to stream the editors from various WinDbg sessions, and so you could, on some way, interact and debug difficult problems together. So technically, everything is possible, but yeah, just need to find the time. Another thing I did, which is slightly like that, it's a prototype where we use Slack at the company for talking internally. And so this is a prototype that reserves a Slack channel, and then whatever command you type on the Slack channel is sent to the debugger, and the output is sent back to the Slack channel. So that's another way to do the same thing.
And so, and the instance of the debugger is running where? In that case, I'm interested in hosting, so the whole instance and about, yeah, for example, the CLR runtime running the DLLs and having access to DLLs which are on remote.
Yeah, so in the case of mention, it was using crash dumps. So the debugger can run anywhere. If you want to debug live process.
Yeah, like a shared database for the debugger. Correct?
Sorry?
Like a shared database for the debugger to access from any machine?
Yeah.
Okay.
And then if you want to do that with live process, then it's going to be slightly harder.